Hi there. Today we are going to learn three important things. First one, why statistics are extremely important. Second thing, how indexes affect negatively to your insert, update, and delete. And third thing, why index can reduce performance of your select statement even when they are not being used. Hi there, this is Pinal, and I welcome all of you to this session where I'm going to talk about indexing. But before I start this session, I just want to say namaste, good morning, good afternoon, and good evening. Today, we are going to talk about index, but in this session, I'm going to make sure that your time is worth watching the entire session. I know it can be very difficult by just watching the screen or watching the guy doing stuff on the screen. I think it puts a lot of pressure on me that I need to really present the content which you may like, and also it's very practical. And as soon as you are done with this session, you can look at your system and say, yeah, I can do this. I can just change few things and can improve the system's performance. So that's my goal. So let's start with that. So welcome. And the session title is Neutralizing Troublesome SQL Server Indexes, Fun Stories and Demos. Actually, I don't have many slides. So whatever you are seeing right now are just few mandatory slides, but don't tell anybody about this one. So with this, we'll start with our very first slide, which you are already seeing. My name is there. And now make sure that you explore everything PASS has to offer. It's about PASS Pro as a local chapter, SQL Saturday Marathon as virtual group and volunteers. Okay, I guess I finished the most difficult slide. And now let's talk about session evolution. So if you like what you see, please make sure that you visit the link, which is going to be on the left-hand side of the navigation bar to the rate this session. Your session matters really well. So yeah, now this is me. I'm a SQL Server performance tuning expert, and that's it. I think that's good enough for you guys. And my contact informations are on the screen. Now, this is our agenda. We are going to talk about how to identify who is creating trouble for our queries, as well as we'll talk about some statistics and how indexes affect our performance and how we can fix it. But the most important thing and the most fun stuff which I'm going to talk about is a scenario where we will see how indexes reduces performance of a select query even though that index is not being used. Now, many of you might have seen similar demo done by me somewhere online or many different places. But today, the fun part is that we are going to see that same thing little bit with more understanding about why it is happening, what we can do to fix it, and why this can be the biggest problem in your system and what you can do about that. So with that said, I think it's our time when we talk about our very first slide. The rule is only one, and that is in this entire session, I don't want you guys to say it depends, and I will also not say that word. Let's remember, there are no it depends. Everything is a science, and everything we must prove with data or some kind of proof or something. We will not use it depends and give any excuse. So Dil, if you really agree with me, just go ahead and write something in a chat window, because I am reading everything and I will make sure that I respond to each of you. You might be seeing me like this on the screen. That doesn't mean we should stop interacting, right? We should just talk like any other day. We are friends, and that's exactly what we should be doing. So, yep, with this, we are done with our slides and time for our very first demonstration. And if you are looking for this free script for SQL Server performance tuning about statistics, how to identify missing index and also unused indexes, the link is given to you on the screen right now on the bottom right corner, where you can just go, drop your email, give a confirmation, and you will immediately get all the SQL Server performance tuning script, which I usually give away for free. Now, with that is done, let's start with our very first demonstration. And for that, I'll go to SQL Server Management Studio. And here we are in SQL Server Management Studio. And one thing I just want to bring to your notice is that the version of the SQL Server which I'm using is actually a latest version of the SQL Server. It is patched with the latest service pack when I'm recording this one. So don't think that what I'm showing you today is on some kind of very old ancient SQL Server or unpatched or some kind of gimmicky thing, or nope, nothing like that. It's the latest version of the SQL Server which I'm using. Well, definitely I'm using Developer Edition, but that's very similar to standard and enterprise in terms of what I'm going to show you today. I know there are differences, and some perfectionists will say, oh no, they are not the same. Yes, they are not the same, but what I'm going to show you today, it will work the same way on them. And as well as, matter of the fact, what I'm showing you right now, or what I'm going to show you today in entire session, is going to be same to all the way to SQL Server 2008 R2. I've tested it myself, it works that way, and that's great. So without further ado, I think we are under less than 5 minutes since we started the session. Time for learning something new. All right, the first question comes in while I'm presenting this thing. It says, what version of the SQL Server Management Studio you have? That's actually 18.6. This is definitely the latest version when we are discussing this thing, right? So with that, I think let's go to our very first demonstration, and let me bring that to the screen. Now on the screen, I have very first demonstration. This is very quick demonstration, very simple demonstration, and will be done with less than 2 minutes. The reason I'm talking about this presentation or this demonstration right now is I want to make sure that you guys understand the real important thing which is driving all the indexes, and that is actually statistics. So let's learn about this one. So it's going to be, as I said, very simple one, and I'm sure some of you already know the answer of it. So that's fun. I'm creating two databases. The first database name is statistics on or status on, and second one I'm calling a status off. Now I created both of this database, and then I am writing the script which is in front of you, which is for one database I'm leaving the auto create statistics on, and for another database I'm leaving it off. So that is done. So before I go further and populate them, I have a question for you. So you guys tell me this question which I'm going to ask, and that simple one is, what do you guys think? Should we leave our statistics on or should we leave our statistics off? What should we do with our database? Now, let me know your answer in a chat. I see few people are writing, it depends. Remember the only rule which we had, we agreed that we will not say it depends. We have to pick one. Think about the scenario that you are going on a freeway, okay? You are going on a freeway and you have to take left or right. There is no way you can go straight. So what would you do? Would you still say it depends and stop in the middle of the freeway while lots of cars are going super fast? No, you'll take a side. You will say, all right, if I don't know if I have to go left or right, I'm just gonna go left right now, and if I'm wrong, I'll come back and take a right exit. See, that's the right way to do it. So do not be afraid to make mistakes. Nobody's perfect. I learned everything making mistakes. Some of the mistakes were very expensive. Some of the mistakes has made me find new jobs, honestly. And some of the mistakes actually I learned at my client's expense in my early career. I'm not so proud on it, but I'm thankful for that understanding. So while I'm talking about all this thing, I did a couple of things, and I know I went a little fast, but those who were watching just screen know what I did. What I created is that I created identical two databases, and both of them has same table. So there is a table inside them, and I have created a cluster index on one of them, and for another one, I've created non-cluster index. So cluster index and non-cluster index. Additionally, I populated both of this database, which has one table each with identical schema, and I populated them with same amount of the data or similar data, exactly same data, and there are 10,000 rows on each of them. Data is pretty random, so it doesn't matter what is in it. Now, what I'm going to do is, first thing, I'm going to enable the execution plan, which I did it over here by just clicking over here. The shortcut is Control M, or you can just hit over here. There is also a way you can go to query in a menu bar and select on include actual execution plan. And there is a first question which is coming in about execution plan. So the question is, What is the primary difference between estimated execution plan and actual execution plan? Honestly, both are same. Yes, that's true. They both are same. So estimated execution plan is the execution plan which SQL Server will use it when it's gonna to execute the query at that point of time when you hit go. So when okay, I'll talk about that in a second. I think I confused three more people right now. A lot of people think that estimated execution plan would be something SQL Server is just guess, and then when you run actual execution plan, SQL Server uses different plan based on statistics. Actually, that is not correct. I would be extremely worried and I would be upset if SQL Server uses different plan than what estimated execution plan says at that point of time. In my career, I've seen only a couple of times where estimated was different than actual one in terms of operators and how the joins and everything came, when there was lots of data being loaded into the table behind the scene, and there was some difference between, like, I ran the estimated execution plan 1 minute before, and then after during that 1 minute, a lot of changes were done, including schema changes. And when I went and executed the query was different because a lot of things change. So those kind of things. But if both of them have done at the same moment, I should be getting the same thing. Yes, definitely actual execution plan has some more real-time data or execution data, which estimated doesn't have it because query did not run it. Now I will run both of them with set statistics IO, and let's see what happens. Again, I hope you guys are learning with me. The point is about not learning about only indexes. The goal is how in the real world we have a conversation, how in the real world we work together to identify what the troubles and what are not troubles. Now, when I go and check the execution plan, I have a very interesting scenario in front of us on the screen. Now, both of this one are identical, my friends. Okay, so look at the top one. The cost of the top one says 37% to the batch, and the cost of the bottom one is 63. So addition of both of them, 100%. Right now it's 100%, but sometimes I've seen it going up and down, but that's okay, right? We know that nothing is perfect and it's just an estimation again. So the top is 37%, the bottom is 63. It's very clear that query on a top knows I have to use index, and that's using index seek. It's also doing key lookup, which is like a lot of people say not good. I agree. But right now the point here is that the query on a top is doing index seek and also using less percent of the percentage, and query on a bottom is doing cluster index scan, and it is actually using more percentage. Now, if you're a perfectionist, you will say, oh, you just said something incorrect. And that is, nothing is incorrect here. What I want to say is that it is not always the case that index seek will be best, and it is not always a case where scan would be bad, but that's what we see usually, isn't it? So yes, I think what we see, we usually like to relate back. So scan in this case also is not good. Now I'll just go, and there is a yellow bang or yellow warning here. And when I mouse over here, it says column with no statistics. And if you're wondering where I'm looking at it, I'm looking at this last row. Oh yeah, blue color. I don't know why it went blue, but look at this is red again. Now I put a red on the top of blue, so it looks ugly even. But there we go. So this is the warning. It says column with no statistics. Why does it say that error? Because there are no statistics. Remember, for the query on a top, I have statistics enabled, and for the query on a bottom, my statistics were not enabled for create and update. The reason why we are stopping here before we go and talk about anything else is what you are seeing right now. What you are seeing is very important. I see this a classic issue at my client's place, and when I show this to them, it's so hard for me to have a conversation. Please understand, you might create any wonderful, amazing, greatest possible index in the world. Your index might be working just fine on your dev system and everything is good. But when you deploy that on a production, things doesn't work the way you think it should work. And also it creates a problem, which is similar to what we are seeing right now. And this is because a very simple reason. What is happening right now with us is because there are no statistics, SQL Server doesn't know even there is an index there, it doesn't use it. Yes, that's true. Even though there is an index, definitely on this table, status of, there is an index. Let me expand and show this to you. So I will go over here and expand this one and expand these tables. And there is it. And here I have index. I have two indexes. Now this index is not even being used because of the classic setting which most of the people I still see at my client's place, at my consultant place, people just keeping it off. And that setting is this. These are the settings which really we need to spend time on it. All right. So, okay, I did not highlight it right. So auto create statistics and auto update statistics. Yes, when both of these are false, at that point of time, it's quite possible your SQL Server even doesn't know which index to use. It will just go ahead and keep on using one index or other index, most of the time the cluster index which you have. And you might get a poor performance because your index, if your table is small, like my table, right now my table is super small. But if your table is really huge, like in terabytes, and this situation can create a lot of problem for you. How can it create a problem? This is how it can create a problem. Think about it. You want to read only one row, but your query will go and do the scanning of the entire table. Now that can be extremely harmful, don't you think so? Because for reading one row, it has to do the entire terabyte read, and that can harm your system. So if you want your indexes to be better utilized and used properly, make sure that you have auto create and auto update statistics on. Now, a couple of people are already writing about this one, and I know your question, so I'll answer that in a second. But before I do, let me change both of this to true, and let me hit OK. So I hit them true, and now after I did that, let me execute these queries again. Now, as soon as I execute this query and see over here, both of them execution plan are identical. Matter of the fact, logical reads are once again established to the same amount of the which is I think we didn't see it before, but I'll share the demo scripts with you. But it was a 55 before, but we didn't see that one because I moved further a little bit faster. No worries, we can recreate this very quickly and I'll show you. But that's not the point which I wanted to emphasize. So let me answer a couple of questions which I came through, and then I will recreate this database and then we'll see it. So the question number one is that we do the nightly update. Question says we do the nightly update of our statistics. So if we do that, do we still have to leave this setting on? Great question. So again, I want to just tell you this very in the simplest possible word. I dropped the table and recreated it, and I just want to show you this one more time because we didn't see the messages before. Logical reads were 55 and 22, and after I updated the statistics or created the status auto create and auto update, it went down to 22. So please understand. So this might be scenario in your night. So in a night, something happened, and you updated your statistics. Now in the morning, your data changed. Your data might have been like 1 terabyte of new data came in, but your SQL Server will still use all the execution plan of the previous night's data. Which means if the previous night it was doing scan like this, it will continue doing scan like this. That's it. Or it will just not do the efficient read. That's what. Are you okay with that? Then no problem. But if I were you, I would still own these two settings, and then I would go and still do the update in the night. I am not against the nightly update. What I'm trying to tell you is that you want your indexes to better use, leave these settings on. And now if your table is very huge or if you have a lot of transactional, I would still go ahead and update. So along with this two, auto create and auto, I would also go and update the auto update statistics asynchronously. The setting which is right now, which is highlighted for you on the screen, I would still go and update this one. So let me change this false to true. And remember what I'm doing right now. I'm not touching these two settings, okay? These two settings are still off, and I'm just enabling this as a true. Once I do that, and if I run these queries again, can anybody guess what would happen? Do you guys think the bottom queries statistics would be updated? Okay, I'll give you 5 seconds to answer this. 1, 2, 3, 4, 5. Actually, no, bottom query still using the same older execution plan. Let me run it again. Still same. Let me run it again. Still same. So yes, so if you enable the asynchronous, it will not be into, it won't be into action till you actually do auto update statistics as well as auto create statistics. Now here, I'm just doing auto update statistics on. Look at the fun one. I'm hitting OK. Now my question to all of you is, what do you guys think? Now I auto update on and auto update asynchronous is on. When I run this query again, do you guys think the bottom execution plan will change or not? And I'm going to give you once again some time. I'm going to give you 100. So I'm going to count 1 to 100, and during that you have to give the answer in the chat window. So I'm starting my count. 1, 2, 100. We are done. Yeah. Okay. What do you guys thought? I'll count 1 to 100. No. That's something my daughter does, but she's now even older. She doesn't do that. So I once again executed the query, and the execution plan over here is still same. Let me run it one more time. After running one more time, it is still the same. Guys, it's super critical for us to understand. Even though I run it 3-4 times, it will be still same. These two settings are extremely critical. When I see them off at my client's place, I just sometimes miss the heartbeat. So leave the auto create statistics on, so it will create the statistics for you. Leave the auto statistics on, so it will create, or it will update the statistics which were created before if they are not as per the algorithm, which is a 10% for the new version and the 500 rows per 20% for older. That's not important. And also leave auto update statistics asynchronous on, because what that setting do, which we are going to see now. So now I have left all three on, and once again I execute. I want you guys to tell me, will this update the execution plan for the bottom query or not? What do you guys think will happen? Now I'll run it one more time and you will see it's immediately updated right now. There we go. It's a brilliant, isn't it? Now the question which comes to our mind, that what actually, so this is normal behavior, but what would this auto update statistics asynchronous will do? Now understand this way the SQL Server used to work before, and that is where we had an issue with it, and that has been fixed now. All right, I said so many things, so I'll slow down and explain you in next 30 seconds. Your index will not be used if the proper statistics for it is not created. For that, this setting is there. If your index has statistics, or if your columns has a statistics and all this thing, but they would not be updated if they are old, has older data or very inefficient data, then they will give you not efficient execution plan. For that, you have this setting. These are there for years in SQL Server. But auto update statistics asynchronously is very interesting thing. That's what, why do people keep this off? They keep it off because of this one behavior. And that is, if you have 1 terabyte update during the middle of the day, like in a 12 afternoon, in the middle of the day, you updated your table. Now, when you write a query previously, so query comes like this, and it will say, oh yeah, I have old statistics. Okay, so it has old statistics. That's what it will say. Your old statistics. OS. I think I'm confusing people, isn't it? So I think I should just write in a new query window. So this is easier and you guys don't get confused. So when the new query comes, okay, so query comes over here, and at that time it finds that I have old statistics. So what does it do? When it finds old statistics, query has one way. What query will do? Query will wait here, and it will update old to new. And once the old is updated to new, query will continue to work with the newer statistics. This is how previously used to work. But with that particular setting, which I just demonstrated to you, the SQL Server works very differently now. What SQL Server does is that, so we have old and new, and I'm just going to draw this with the blue line. Query came over here and it identified there are old statistics. It will tell the engine said, go ahead and update the statistics, but I am going to currently use old statistics and continue my journey. So for that one time, it might use the older statistics and will not hold your queries. And behind the scene, it will update all the statistics. So next time, your query, which used to sometime wait 1 second, sometime it used to wait for 5 minutes. I have seen queries waiting for hours also sometime for statistics update when the data was huge and drive were slow. Middle of the day. Now that won't happen. Your query will still go through with older statistics and your statistics will be updated behind the scene with a new one. So that is the power of that particular setting. So if you have OLTP, I strongly suggest you consider this one to on. Again, it goes without saying everything you must try it on a dev system first. And once you pass all your unit tests, you are totally confident, run everything on your staging. And once you are confident, create a rollback script and deploy on a production. Nobody does that nowadays, do they? I mean, my clients, I have to tell you business secret, 50% plus time, I just have to work on production. And I'm also equally scared at them. So I tell them, take a backup. I can't take 100% responsibility because you don't have a dev system. But, most of the time, SQL Server is pretty robust product and Microsoft team usually is a bad, not good word. Microsoft team has mostly done fabulous, amazing job to make sure that SQL Server runs awesome. There has been some bugs, but who doesn't create bugs? Sometimes I make mistakes too. So bug is maybe as a developer, it's our right, I should say, isn't it? But anyway, it usually does a good job. Now we understand why statistics are important. And there are few things which I get in trouble. Like I created index, my index is not used. Well, go and update the statistics. No, that won't fix it. What you really have to do is that make sure your auto update, auto create statistics are on. So for entire table, right now I had one table, but in real world, there will be so many tables, so many joins, and you always need to have a better statistics for it. So that will solve most of the problem. So if you ever come to me for performance tuning consultation, there are 2 to 3 questions I usually ask. One of them is that what are these 3 settings are set on? If they are set on off, I don't want to take your project because I know if I go and turn this one on and your SQL Server is gonna to work very fast, why take money for something so simple which I can just share with you in one line? There may be a better, more complex problems come for that, but not for this one. So that's one of the things which you should do. Now let's look at why I do not like indexes. So one of the classic question which I asked to my client, let's talk about that now. And that question is, how many indexes do you have on your one of the important tables? So think about it. I think this is a very important conversation and I really want to do with you right now. You have a main table. Like everybody has a main table. Like I can ask you, each of you, and say, can you guys tell me which table is key table, important table for your business? And I'm very confident all of you will say, yeah, this table, that table, or maybe you come up with the 3 or 5 tables, isn't it? You come up with these 3 or 5 tables and say, you know what, these are the important tables for me. And my next question is going to be, how many indexes do you have on them? What I'm really looking for you to tell me is that too many. If you come back and say, I have 10 indexes on this table, 7 index on this, 20 index on this, or any number which is more than 5, 6, or 7, I just think I know I can take your project. See, when I do for performance tuning consultation, I only want to take the project where I can contribute and really improve your performance, right? I mean, why would I take a project which I can't do? That would be just try and error. That's great. When you're beginning your career, that's great. When you have dev server, that's great. When you are learning yourself, but it's really not good when somebody's really paying you seriously good money, as well as also the business is serious, right? I mean, you don't want to do try and error on a client's place. So if you have a lot of indexes, I'm happy because I know I can help you immediately. More indexes I remove in my life, I've given a better performance to my clients. We should always create better indexes. But what do you mean by better indexes? What is proper indexing? So let's learn about that in next 30-35 minutes. And there are 2 demonstrations I'm going to show you. The first demonstration, I would be a little bit faster, but then the second one is where I really want to slow down and ask you a few questions. Let's go back to on the screen, and here we have a small table. Oh yeah, first question comes in, why are you using TempDB? The reason, okay, I can change it to any DB. I can just make it a SQL Authority database too. So because, all right, so you guys want it, okay, I'll change it to SQL Authority. Yeah. So the reason I use the TempDB is very simple, because I do this for living, right? So I go to different clients' place. I also do an online presentation. And every time I just create any object, like I'm going to create right now, which is called first index, and then I would forget dropping them. So when I restart my computer, the TempDB is automatically created, and I don't have to explicitly drop all the object which I forget to drop. That's the reason I use the TempDB for demo. No other reason. I think a couple of your concern was that TempDB has a different mechanism. It does have a different mechanism, but it won't affect my demonstration. So what I'm going to show you is that I created a small table inserting around 100,000 row. I'm just watching chat window to somebody to correct me that I have 1 million, not 100,000. And there you go. Few people, Eagle Eyes guys, Eagle Eyes attendees has really said that, yes, you are right. It's a 1 million. I just wanted to make sure that you are watching the screen. And while I'm doing this, you're not doing something else. So this query took around 4 seconds to complete. 4 seconds to complete. I'm going to truncate it one more time, because some people will say, oh yeah, it will take first time caching thing and things. So yep, I get it. So what I'm going to do is set statistics IO time on. I have done that. And then after, I am going to run this same query one more time. So here I'm going to insert one more time the data. Data is random. Let's see how long it took. You guys were right, isn't it? But this is not because of caching. It's because of file growth and other things. But let's not worry about it. Let's remember that it took around 2 seconds to complete this query. Now I'm truncating one more time, and then I'm creating 10 indexes on this table. And I want you guys to tell me how long after creating this 10 index this query will take to run. It's absolutely same data, and I want you guys to all of you to guess it and tell me how long this query will take to run. And that's it. So please, every attendee, all of you, please go write in a chat window, or you can use the question answer one as well, and just say, what do you guys think? So situation is, one more time, table, I've created 10 index on it. I'm going to insert the same amount of the data, which took 2 seconds. How long this query will take now? Write your guesses in a chat window. Oh yeah. So allow the conversation. You guys are very good. Okay, so many of you are writing, and most of you are saying more. More is correct answer for sure, but really I'm looking for the number, right? I mean, how much more? Let's see. So yep, query is going on right now. My friends, it is already crossed 10 seconds. Let's see how long it takes. I am quiet right now and creating uncomfortable silence for you. I am not speaking at all. 30 seconds. Yes, it's done. All right, it took around 32 seconds. Query which took 2 seconds now is taking 32 seconds. Why? This is because of all the indexes which has been recreated. So what happens at the time, SQL Server, when you are updating your table, it has to also maintain all the non-cluster indexes, and all the non-cluster indexes also are actually object from then on, and they also create IOs, lot of IO, which actually leads you to 32 seconds. So please understand, very interesting behavior over here. Query, which was taking 2 seconds, now took around 32 seconds. Every index which has to additionally maintain, it has actually, so think about this way, 10 indexes, previously query took 2, now it's taking 32. If it was a 10 times more, right, 11 times more, it should take around 22 seconds. Okay, let me explain you math, what I'm trying to do. So one index, one table 2 seconds, right? 2 sec and plus 10 indexes. So I have 10 indexes. I should have a plural over here. It should take 20 seconds. So actually it should take around 22 seconds, isn't it? But it took 32 seconds. All right. So every index which we added actually created a lot of burden on our system. That's why I see more than 5-7 indexes. I was like, oh yeah, I know there is a problem. We need to go and drop these indexes. This script, which you can easily get it by going to this URL, go drop your email address. It will send you confirmation, confirm, and in the email, you will get a link to download this unused index script. Now, what this script actually do is that it actually shows us all the index consumption in our database. So in SQL Authority database, this is the index consumption for all the tables which I have. But right now, as you know, there is a single table. That's why this is what it is. So this actually shows us index consumption. And it's very, very clear to us that we have retrieved the data from our main table around actually none, 0 time. There has been no seek or scan. So there has been 0.6. That means there was not a single time data was retrieved. There was no scan. That means there was also, it didn't use the scan mechanism to retrieve the data. Matter of the fact, none of them was also used for lookup. So pretty much all of them were update, and that's why it is 1. So in real system, you will have a different number right now. Like some index will have a very high number, some index will have a low number, and that will give you guidance that which index are really used more, which index are used less, and based on that, you can come up with your own algorithm. So consider this as a starting point. Do not believe this script 100%. And also there is a negative thing about this script is that once in a while, it also gives you false positives. So always take a backup. Now, this script is accurate from the last restart. So since you last restart, it combines the data. So it's always a good idea to use this script once you have been using your system for around some while, right? Not, 1 week or maybe a month. And then after, come back over here and start evaluating your indexes. If you see the table has very little user seek and more user updates, that index you would start considering is a bad index, and you may consider to drop them. So user seek should be actually, it's a good idea to have a huge number here, large number here, and user update should be less. That's considered as a good index. Otherwise, you may consider as a drop candidate. For example, I'm just going to do, because I am on a dev server, I can do this thing. So I'm just executing and dropping all these 10 indexes, which actually were here and I knew were not being used. And after that, I come back over here, truncate the table, and then I will run the same script again. And now the same script which I'm running right now is going to take very, very little time. Well, it took around 3 seconds right now, more than 2 seconds. But yes, the query was done. It didn't take 32 seconds. You can see it's a difference. I can truncate it one more time and we'll show you again. And it may take the same amount of the time or less. So this is what I was trying to tell you, that if you have a lot of indexes, I actually know this time it took 2 seconds, that I can come to your system, drop those indexes, and there you go. We gain a better performance out of your system. Now, these are all good. This you might be familiar with it. But what is really we are going to see next is the key of this entire session. That this is given. We know instead of the delete. Yep, we know that those indexes are slowing down. But right now, we are going to discuss about very interesting scenario. We have a query. The query is running very slow. We will create a very first index. Once we create the first index, our query will start running faster. After that, we'll create second index. When we create the second index, our query will start running slow again. And we wonder why that is happening. For the same reason, we'll go and drop our second index. As soon as we drop the second index, our query will start running faster. Now, when we create second index, query runs slower. When we drop second index, query runs faster. While all this time, when we check the execution plan and our statistics, we figure out that our query is only using first index. even though our second index, which is not being used, actually reduces our query's performance. That's exactly what we are going to see in this demonstration. Let's start. Here we have set statistics IO on and already enable execution plan. We are also using sample database, which is AdventureWorks, and now I'm going to execute this query. When I execute this query and check execution plan and ask you what we should improve in this execution plan, what would be your answers? Yeah, please go ahead, write in a chat window. This time I'm not going to count 1 to 100. Maybe I should count 1 to 1000. What do you guys say? 1 to 1000. All right, we're done. What is your answer? What do you think is wrong in this query? What should we improve? Which operator looks a troublemaker? I would like to really see what you guys come up with it. That's why I'm giving you this little bit time to look into this and improve give a suggestion for improvements. All right. When I see this chat window and I see your suggestions, I think it's very clear most of you are saying that nested loop is something which we should improve. And the second set of people are talking about cluster index. A lot of people are saying, yeah, this cluster index looks like extremely expensive and we should convert that to something else. Maybe scan should go to SIG or something else, or something should happen here because this looks like, yep, 42%. Okay, couple of folks has also said the table spool looks like a problem. It can be. I can't say no to that. Yes. Okay. So now we look at the messages. This is going to be fun. But before we look at the messages, just as soon as we look at the messages, we figure out very interesting thing. That's a work table over here. Do you see this work table? It says logical read is very high for this, whereas cell sorter detail has logical reads very little. All right. So all this, we can spend more time on it, but I think we are running short on time, isn't it? We are going to do a quick fixing it, and then we'll come back to this. Actually, I know if I explain you more, you will get the answer to the problem. That's why I'm just actually not trying to explain that. All right, so look at this work table, very huge read, cell sorter detail, very little read. Now work table is actually temp table, so temp DB's usage, that's what it is. Now I can update the statistics. Couple of people are saying, why do you not update the statistics? All right, I updated the statistics and I go and check the execution of the query. And when I look at this, it says same numbers, guys. So yeah, update statistics doesn't do anything right now. So I am going to create an index on this one. And now the best practice says always create index on the where clause, isn't it? So I think you guys have to help me out to create index on the where clause. So yeah, tell me, what should I have a first column? Should I have a product ID as a first column, or should I have cell sorter ID as the first column? What's your preference? What do you guys think I should have a first column? I'm super interested to know this one. So okay, few people are saying product ID should be first. Few people are saying cell sorter ID. You know what? I'm going to create two indexes. First time I'll keep the product ID first, and second time I'll keep the cell sorter ID first. How about that? Or vice versa. I'll just change them. So here is the first index. Okay, first index is over here. This time I'm going to keep the cell sorter ID first, and then after product ID, and I'm including two columns, which is part of the select statement, which is cell sorter ID detail and order quantity. Both of them are over here. So let me just create this index. Okay, so I just created the index. And after creating index, I'm going to run this query. And then we will check the execution plan. Let's look at the execution plan. And now, hold on. Previously, we had only one scan. Now I have two scans. Scan number 1 over here on the same table. And the scan number 2 is also happening. I think I just made this query worse. Or maybe not. Or maybe not. Look at the logical reads and you can figure it out that logical reads are so little right now. There is no work table. There is no temp DB reads. It's just little number. This is awesome. Our index is really doing amazing task. But you know what? Maybe we can do even better. If we just create second index with product ID as a first column and cell sorter ID as a second column. Please note that I'm not dropping the first index at all. I'm just creating this second index, which you're seeing right now. And I created this second index. After creating the second index, when I run this query, oh, for a moment, I just went to messages, but I really wanted to come to execution plan. Look at the execution plan. Once again, we have one scan. So that seems like a good thing. But then we have a table spool back. What are these table spools? So when I read the table spool, it says, store the data from the input into temporary table in order to optimize rewinds. It is optimizing something. Okay, it's a very complicated explanation. I'm going to make it simple for you. So what SQL Server is doing right now, so it doesn't have to keep on going back to original table. It pulls the data from the original table, and then after it inserts all of this data into temporary table. So instead of accessing original table like 1,000 times, 100,000 times, it is now only accessing our temp table. So that way it is optimizing it by storing the copy segment or smaller section or subset of the data into temporary table. And that's very efficient. It works most of the time. See, please understand, SQL Server team would have not done something without proper thinking and testing. As I said, mostly amazing. Once in a while, there is a data, statistics, and things. It might give you some different results, but the intention is correct and it works amazingly fine in most cases. I'm so grateful that they always listen, feedback, and improve. Now, coming back to this particular point, table spool is back, but when I look at the messages, oh, look at that. Once again, we have huge amount of the reads and sales order details are there and work table was introduced. And when I go and check over here, it says my query is only using the first index. There is nowhere in this entire execution plan there is a mention of the second index at all. So what I'm going to do is that I'm going to drop this second try index. Second index goes away. As soon as I drop the second index and run, okay, this is the same query. It's just index forcing over here. So this is actually the same query. When I run the same query, after dropping those indexes, right? At this point of time, once again, we have little logical read and our execution plan changes. Now, let me just recreate this second index. So I'm just recreating the second index. As soon as I recreate this second index, please look at this query's performance. This query actually now entirely changes in terms of execution plan, but your IO also increases. And now, if you are not believing, I'm going to tell you this. This query doesn't use second index at all. Still, it does that. So to make you believe, I am going to put this query hints. It is explicitly telling that use the first index only, isn't it? Now when I run this query, look at the execution plan, still bad, huge IO read. What? Why it is so? Let me drop the second index. I drop the second index and I run the same query again. Oh, this is different, crazy. Look at this. Logical reads are set. So even though I have a query hint over here, when I just create this index, which I call a second try, just being in existence of this index, this can slow down your query's performance. Whoa, isn't that crazy? Isn't that crazy? Yes, it is crazy. But are we sure this index is not used? Well, I put a hint. But if you want, I will just go to this unused index query and will run in AdventureWorks database and see what happens. Here, I see nothing. Look at the first try. Yes, first try index is used 10 times. There is no mention of second try index at all. This second try index is not even being listed there. This index, when I create this, it's already there. Even though it's there, when I run this query, this query is using first index. See, look at this. Its second try is first try is 10 times. Now when I run this thing, it is 11 times. There is no mention of second try at all. Now, when I go and drop this second try, well, I dropped it and run the same select statement which I had used again, you will see this 11 jumping to 13 and second try is not there. As a matter of fact, the index is not there at all. But this query is awesome. Now, here I'm going to stop and I'm going to ask you why. Why do you guys think that is happening? Why select statements or query like this is negatively impacting, why index like this, even though not being used, negatively impacting the query's performance? What do you guys think about it? I will give you like a 5 to 10 seconds to just go and update your answers. I'm very curious what you guys think. I've seen it at my client's place all the time. Matter of the fact, this 3 days ago, I was helping my client. They had this issue. They would not believe me. They would refuse to drop all these indexes. I keep on telling them, I said, your indexes are problem. Said, no, they are not being used. I agree. Indexes may not be used. And that's why you need to drop them. But it's not being used. I just want to keep it because sometime in the future I may need it. I agree. But your index just being there is negatively impacting everything else. No, I need to fix this. Honestly, I gave up. I said, if you don't want to drop your indexes which are not being used for a longer period of time, nobody can help you with performance. And eventually they came around and we dropped it. I know it's a sad story, but it's a fun story too. When you look at my perspective, I was so happy. I actually knew they had a 20 or they have actually 22 indexes on the table. Out of the 4 or 5 were good enough. And that we figured out by this unused index script. If this number is higher, like seek is higher or scan is higher, right? We know that that index is being used and I should be keeping it. But if I just don't see them higher, I know they're just not good and I can just take the drop script and run it and I can get it. And eventually we dropped few of the indexes and we got amazing performance. But so what is the story? Okay, so there are 2 things right now pending for us to understand. Thing number 1, and that is why this is happening. So I'll answer you that in the most simplest possible way. This is because all because of statistics. Even though we think the index is not being used, that's not the real reason. Always the real reason behind all this is statistics. Okay, so let me just recreate this index first. So after I recreate this index, and then after, when I run the same query again, it gives us very poor performance, very, very poor performance. So this gives us very horrible performance. Look at the execution plan. It's still the same bad. I mean, it has a couple of spools and things. But when I see this one, we believe like, oh yeah, it's not using that index because I went and used this unused index script. But when I look at the execution plan and look at the execution plan XML, so execution plan may lie a little bit, but show plan XML or the plan XML doesn't lie. So when I look at the optimizer states usage in this one, look at that. It is using few of the statistics to make decision what kind of execution plan it has to build. And over here, the drum rolls, I don't have that effect, but look at that drum roll. It's using the second try index. And it is using the guidance of the second try index, which is there. Matter of the fact, not only second try, it also uses product ID, row GUID, sales order detail ID. Pretty much every single index you create in your system will be used in your execution plan to make a decision for building the execution plan. All right. I'll say it simple possible word. Every index you create creates statistics. And every statistics impact your SQL Server execution plan's decision. That means even though you might think the indexes are not being used, their statistics influences your execution plan in such a way, sometimes you make a better decision, sometimes you make a worse decision. You really do not know if your execution plan and index are going to make a right decision or wrong decision for your query. How do you fix that? Well, there is no real scientific clear answer over here. So to reduce this kind of behavior, to reduce this kind of effect, to reduce the confusion for optimizer, to reduce the confusion for yourself, what you can do is to play safe. Remove all those unused indexes by the script which I just showed you, the indexes which has a lower usage, the indexes which are really not used very much. Remove them so they, whatever their potential negative impact might be there, you can expect not to be there. Reduce the error of margin of error. Reduce the margin of error. Sorry about that. Yeah, I got it. Yeah, thanks for correcting me. By removing indexes which are not used. And when you remove the indexes which are not used, you already know your insert update deletes are going to be faster. If your insert is going to be run for 1 minute, every single select on a top of it are also going to wait. Well, that's the reason why you should remove most of the indexes. Long story short, have only those indexes which are useful for your system. Frequently check your index consumption. Remove the index which are not frequently used. Once you start reaching 5 to 7 indexes, it's always a good idea for you to start evaluating each index, its consumption, and its behavior. So today, without using it depends word, we achieved quite a lot of ground. And I just want to say thank you, but there are a couple of things, so don't go away. Yeah, this is the contact details. You can ask me any question. If you have not understand anything, if you have any performance problem, if the performance problem is very complicated and cannot be solved easily, I love to take those kind of challenges. So please send it my way. My email address is on the screen. My Twitter handle is on the screen. If you can't reach me, you can just always say pinaldave@gmail.com. That's also my email address, which I check. And I want to still explain more if you are confused. So I'm here right now live with you guys, and I would be happy. I'd be happy to answer you more. So please post your question. Make sure you fill up the feedback and reach out to me with your any SQL Server performance tuning question. I also have a YouTube channel where I post many of this interesting videos. I call it SQL in 60 seconds. And you can just watch it. It's just a bite-sized learning, little things I try to teach in a little time. So yeah, with that, yes, fire your questions. I'm here to answer, and let's have a conversation. We are here to talk to each other. So thank you guys, and yep, have a good day.